DTE, DCE, data terminal equipment, data channel equipment. Now, those two terms alone can kind of give you a clue, at least somewhat of an idea about what they might do. When I say terminal equipment, it sounds like something that's at the end of the line, a terminal device. And when I say channel, it sounds like something through which information flows. So you're already on to an understanding of what they mean. But I've got to tell you that these are difficult concepts. And I can describe them to you, but you probably will not fully understand them from my short description. It's best to go to Google and then read several articles about DTE and DCE. And as you put the information from a whole bunch of articles together, eventually you can sort of begin to understand how they work. But we will go through a short description. First of all, those terms are entwined in some other terms: CSU, DSU, Channel Service Unit, Data Service Unit. This is a device. By the way, this is not two devices. You don't have a CSU and a DSU. You have a CSU, DSU device that the ISP uses to connect a customer to a WAN connection, such as, say, a T1 line. Now, that customer has a router on their premise, and that router acts as a data terminal equipment. And the CSU, DSU owned by the ISP is a DCE, or data channel equipment. It looks kind of like this. Here's the internet out here, and this ISP, this client over here wants a WAN connection. So the ISP puts in these two CSU, DSU units, which change this local traffic here to this WAN traffic, and then back to local traffic again. And so that's what these CSU, DSU units here are doing. They're just changing the signal to the two different types of traffic. All of this is a DCE. This is the channel through which that information flows, the DCE, data channel equipment. And then the terminal equipment is over here, and that's the router, which is owned, in this case, by the client. So that is the data terminal equipment. Now, the DCE, by the way, provides the clock, the pulse by which the DTE is able to march, so that they can talk in sync with each other. Now, what does all this mean to a person studying Cisco? Well, I'll tell you what it means to the person studying Cisco. In the lab, when you're connecting two routers with a serial cable, now when you're connecting them with a serial cable, what you're doing is simulating a WAN. And one end of that cable is going to be marked DCE. At the other end is a DTE. That's not always marked, but the end that's not a DCE is a DTE. And when you connect these two routers together, the router interface at the DCE side of the cable has to have the clock rate set in order for the communication to occur between the two devices. And then the DTE interface on the other side will receive the DTE connector on the cable. It's going to look something like this. So I've got two routers. I've got a serial cable that I put between them. One side of the serial cable is marked DCE. And on this, I'm going to perform a command. This is the prompt over here, and then here's the command, clock rate 28800. It could be several different numbers here, but I've just chosen this one as one example. And then this one now is providing the pulse by which this guy over here marches. So this is why we use it in the lab to create these WAN simulations with a serial cable between two routers.